So, hello everyone. So, this is another question of the OA series we have just started. And this is the first question. I won't reveal the topic now, as of now, because someone commented that you don't reveal the topic because it will just diminish the whole idea of the OA question, right? We don't know the topic, right? So, I won't mention the topic. I will just simply making a single playlist of OA series name. And then you have to tell me what is the topic name by reading the question before I will disclose the topic. Okay. Then I will see that who knows the topic, right? Who understand the problem clearly. And also this question is commented by someone. I didn't remember the name, but he told me to make a video on that. And here it is. So I read every comment, each and every comment. So if you have any question, just put it down in the comments. I will see if it's a good question. I'll surely make a video on that. So, and yeah, if you are new to the channel, make sure to hit the subscribe button and like the video, and let's get started. So the question is, you have an inventory. It's a big question. It's a medium question. I would rate it's not easy medium. It's a medium question. I generally rate a very good thing. So sometimes I make a medium to easy, hard to medium, but it's a medium. It's a medium only. Yeah, it's a good question. Okay. So it says that you have an inventory of different colored balls, and there is a customer that wants orders balls of any color. Okay, he just don't care about colors. He just want that much order number of balls. Now it says that customer weirdly values the colored ball. Each ball is the number of balls that color that you currently have in your inventory. Okay, for example, if you own six yellow balls, the customer would pay six balls. It's very, it's like just opposite that you have more balls, you have more cost. Let's say you have six yellow balls, then the first ball will cost 6 rupees. Let's say in Indian context, in $6 you can say, and then it will go and reducing. Let's say then you have five balls, then the next ball, the fifth ball will cost $5 and so on until till $1, right? $1, 1 rupee. So it's gonna be like that. The understand you should understand this clearly. Okay, that's fine. You're given an integer array inventory. The inventory of I represent the number of balls of the ith color that you initially own. Okay, means that we have certain color of bulb. We don't care about the color, but we just know the number because the number is important that determine the cost. Okay. You're also given with the integer order, which represent the total number of balls that the customer wants. Okay. So customer wants some number order number of balls. We need to fulfill his criteria. You need to sell the balls in any order. He don't care about in which order you sell. You can order. Let's say you have six and five in the array, right? So you have six ball of some color, five ball of some color. Let's say you want to sell only two balls. So what is a good way to maximize the profit? You firstly sell this ball. You get 6 rupees. Now let's say it's four actually. Yeah. So you will again sell this ball only, right? Because you will get 5 rupees. Because when it will reduce, it will count only five. So you will get a profit of 11. Instead, if you gone from four, your win profit would be only 10. So we won't want that. So we got 11 as the answer. The orders was. So I hope you got the intuition that what the problem is trying to say. And then it finally says the maximum total value you can attain. Like it's understood that we want the maximum value. That's all we can understood. So answer modulo 10 power minus 7 because some could be larger. That's particularly fine. So this is pretty decent question that after reading the question, you don't get any idea because the complexity is actually good. You have inventories also till 10 power 5. You have what orders also of 10 power 9. So too much thing. And also topics mention some random shit. It's not like that as well. Right. So okay. Orders is also the huge and numbers values are also of 10 to power 9. The inventory of I. So we are not getting any hints from constraint itself. Now, how do you approach then this kind of problems? So you keep your calm and let's try to observe something that what we can do. What's the greedy idea I have shown in the example? That yeah, it's better always to sell the greedy means the expensive ball first, right? That's particularly fine. But till which point we need to stop? Let's say we have five, we have four, three, and yeah, let's say five, or let's say four. Yeah, this kind of thing we have. And then let's say we want 10 orders. So at which point, let's say we sell this, then obviously we'll sell this, then we will sell five, and we'll sell five, we'll sell five, we'll sell five, and let's say we sell four. But when do we stop? Sometime it could happen, right? We sell all the balls. That's also a possibility because that's the number of orders they use. So we don't know at which cost we need to stop. So did you get the idea from here? So is it better that we always put sell the all the balls above a certain price? Let's say, okay, is it better? Is it always valid? No, not always. Why? Let me show you an example. Let's say you have two, and let's say you have four. Okay, you want to sell, let's say, three balls. So what you will sell? Four first, then three first, then both becomes two two. So you want to sell two also, right? So you have to sell two as well. So this, it's not like greater than always a particular number. You can say that all balls above K, all balls above K, definitely we will sell. This will always a valid K always exist, and some K balls as well. Some of K balls as well. Balls as well. This is mentioned in hints, and that's a very good hint. And people are not able to understand what the meaning of this. See, try to understand. We have two twos here, and we have order of three only. So it's not required that you sell all the two. Here K is two, by the way. You don't need to sell all the twos. Only some two means I sell only one two. Then our my answer becomes four plus three plus two, which is nine. Beautiful, beautiful question. Okay, did you get a idea of what is this K and how we can determine this K? Is it something feeling? I will really reveal the topic now. So the idea is monotonic, and yes, you guessed it right. It's binary search, and it's a beautiful question of binary search because we generally solve questions regarding binary search on answer. This is a good variation of that, and it's not giving the hint. Generally, binary search on answer questions are pretty straightforward. They give the hint, but it's not. That's why I picked this question to explain you the logic. Cool. Now, how do you go about that? So we have to find this K. So what's our logic? Let's say, let's say what I'm defining my, obviously I have to define a check function. Always we do in a binary search of on answer question, right? So what is this check function will tell me whether I have to go up or whether I have to go down, low increment or high decrement, whatever, right? So let's say my K is very small. What will happen? This will end up picking orders possibility always. Like large orders will get, right? Because more number of orders I will get completed, right? So if that happens, what should we move? What do you think? Should I move the K up? Yes, right? K should move up because I want more K, right? I want more K, more profit. Move K up, up. And then if it is not possible that with this K, let's say I pick very large K. Let's say we have six, five, four, and I want to complete orders. Let's say four orders. I cannot pick five, right? I cannot pick five. Why? Because I will, let's say I pick six, five, and five. I completed three orders. That's perfectly fine for five. But when I have to complete one more order, so I have to pick four also. That's very important. Means this is not a valid case because I have to complete my order. That is my first priority. Then my second priority is to maximize this. Right? I have to complete the orders. And orders are in such a way that some of the elements are always zero or not zero means till we can fulfill all the orders, right? Cool. That means okay, so K is something, so we will determine, we'll check the mid, right? Okay, that makes sense, that makes sense. Then how will we go about that? So what we will do, we will firstly count how many elements we can get, how many orders we can complete greater than K. We'll count, let's say this is C1, which is orders greater than K. Okay, we'll count these. And then what we'll do, and then we will also count greater than equals to K. Means because sometimes K, either some orders are K itself or some orders reduce to K, right? So there are two possibilities of K. So greater than also, let's say this is C2, right? And then we will check whether C1 plus C2 can be fulfilled with orders. That's all. This is our check condition, right? Why I have done this greater than equals to k? Again, understand in this example itself. Let's say my orders is 6, right? So what I do? 6 reduced to 5, then reduced to 4, 5 reduced to 4, and then we have 4 also. So how many orders we completed? 6, 5, 4, 4, 4, 4. So technically we picked three fours. We initially don't have fours. We only have one four, but this two four we got while we are transforming, right? So that's why the C1 plus C2 is orders. Then we can complete. We can need some of the C2 only. Some C2s only required, but C1 will be definite. C2, okay, fine. So this should be this, and then it will be move our k up and down. That's the entire logic. And then what we do, and when we find k, let me just show you how we will calculate the answer from there. So let's move to the solution. Cool. So we'll also try run the example after a bit. But yeah, let me just show you the exam code first. Then we'll try run the example. So what we'll do? See, we want to maximize the profit. So firstly, I will sort the elements into the reverse order. We'll see why we are sorting the elements. Okay, it's not required as well, but it's a good thing you can do that. So we require the low to be 0. Why? Because my k means what I'm doing, I'm finding a value which is greater than something, which is greater than something all I can sell. So it could be 1 also, right? I can sell all the ones. So we will define the low to be 0. And what would be the highest? What highest I can sell? Like inventory of 0 only, right? Inventory of 0, because I've reverse sorted it. So reverse sorted it. That's why this is the largest, actually, largest element. That would be the largest possible range, right? Largest possible cannot be greater than that. Would be lesser than that only, but it could happen only one order. So this will be fine, right? So I initialize my k minus. We can initialize with anyone. Now this is a standard binary search. So plus I calculate mid. It do a check. Now I already told you, if I found this mid to be good, we'll push this mid. I will increase my k. I just want to more and more k should be increased higher and higher, so I get more cost. Okay, let's see how we have implemented this k. So I already told you this we are how we are calculating the number of orders can be satisfied which are greater than k. So let's say my orders, I need to let's say my k is currently, let's say I'm checking for particular k which is 4, and my orders are 6 and 5 and 4. Okay, so I go to 6. How many orders I can complete above k? So obviously 5 and 6 definitely. So two orders I got from here. From here, how many orders I get? One order I can get. I don't get any order from here. Okay, but when I'm checking k equals to 4, I'm also, this is my c1. C1 is 3. My C2 becomes, tell me in the comments, what's the C2? See, this is becomes also 4, this also becomes 4, this also becomes 4, C2 becomes 3. So if my orders are 6 or less than that, I can satisfy this, right? I can satisfy with this K. So that's the entire idea. I just do that. I just early return itself. If they're greater than orders, I return true. Also make sure that keep off long. Why? Because count could be larger, right? We're calculating the sums, or this could be 10 power 9 range. Make sure to make the long as well. So at the end also, we just checking count plus c is greater than orders and also or not. Now, this is the important thing, that how we, after getting the care, also there's some math involved. So what we are essentially doing is very simple. It's not too much complicated. So I took just variable, rename the variable inventory of I to balls of I. Okay, this is uh okay, this is fine. This is also not much required, but I just made that sure that cool. So what we are doing it. So firstly, I'm reducing the orders which I can satisfy now. Okay, I found the k. Same concept I did. I minus k, right? Above, which is balls minus k. This is same thing. Cool. And then what I calculate the sum, right? So let's say a 6, 5, 4. We already took this example, and then we are at 4 orders we have to satisfy. So what will be the cost? I have to calculate from 5 to 6 sum, right? I hope you're understanding. How would I calculate this sum? It's very simple here. 6, the sum till 1 plus 2 till 6 minus what? The sum till 1 plus 2 till k. Because I want to sum from k plus 1 to inventory of I. That's only the sum, right? The cost sum, which is equals to what we are doing, balls into balls plus 1 by 2 and k into minus k into k1 by 2. I store in s, just calculate and add it to our sum. That would be the answer, right? This is fine. Now the remaining thing is whatever orders are remaining. Let's say there are some orders remaining, because I already told you, right? Some k will be used. Now these some k's will be used. So all value, the cost will be the k only, right? Well, sell, not cost, but the selling power will be k. So this will be multiplied by the whatever orders are remaining. So this is pretty simple for that. And then we got a mod, and then we read this. Also, let's try to do a quick dry run on this example. So you can check it out. I found this k to be 2 here. You can check out with more k. You will not able to satisfy the thing. So let me just show you how, with the help of k equals to 2, we are able to satisfy this. So what we are doing is, we, let's say, reverse sorted it, right? So reverse sorted it. Firstly, we got 5. So we will add to our orders. How many orders will be reduced? Orders will be reduced greater than k. So means we are getting 5, 4 or 3. We get 3 orders reduced. Our orders becomes 1. What is our sum becomes? Sum becomes 5 plus 4 plus 3, which is 12. Okay. I go to 2. Now I will break off because this is not greater than k, and k is 2 itself. Now I will go. How many orders are remaining? Only one order is remaining. And then I will multiply with 1 into 2, which is 14 is the answer. That's a very, very good question. Do let me know if you understand the entire intuition, the entire concept. And if you like the video and you're still here, to make sure to subscribe to the channel. And I'm coming with more awesome content, more good questions, and you will learn it, right? So bye bye guys, and see you in the next video.